energies. So there are so many conversion and so many value additions are there to the waste, and lots of industries are coming to for this, and there are so many ppe models are also going on how to make this plastics waste to the value additions. Now, the scope of the presentation is what is the consumption in India right now, and what is this product demands, and where is this plastic waste generations and challenges, and what is the waste recycling and its value addition, how we can make a value addition, and what is this CPET's initiative for this handling of this plastics recycling. Now, if you look at the scenario of the solid waste, now the solid waste means it all comprise of the municipal waste, and it comprises of the plastic waste. So, plastic waste is no more less than the other solid waste, and the lots the major cities of India like Delhi, Ahmedabad, Mumbai, Pune. So, whatever the cities, they are generating a huge amount of the waste, and it is even 6,800 metric ton per day in Delhi, and whereas in plastic it is around 102.98 kg per metric ton. So it is the capacity per day, which is considered as a very huge amount of the waste, and this much of waste are generated per day. And the really challenge is that how this waste can be handled, because the situation is that the most of the plastic waste when we can't use now it is in road, and if that cannot be collected by these recyclers or rag pickers, then ultimately they are going to our ecological environment like resources of water and sea and river, and they are making polluting everywhere. Though plastic is not biodegradable, the major issue is that these plastics are not biodegradable, and they are cannot be compatible with the soil. So they wherever you are throwing this plastic, mostly they are laying there, and if it will be not collected this waste, then ultimately that will be live inside the soil even 100 years, and it will not degrade with the soils with bacteria. It cannot be consumed by bacteria. It cannot be degraded by this chemical. These chemicals cannot be degraded by this UV or something. So it will all retain, and gradually it will reduce the weight. But wherever the teeny particle they will retain, and they will gradually pollute this water, and whatever we are drinking the water, that will also get polluted. So this consumption, if you take a look about the consumptions now, growing a very high rate, and India it is ultimately it is a growing country now. The India is taking the consumption in India plastic is growing tremendously in a potential way, and even these plastics are giving a very good boost to our GDP. But whereas the ultimately at the end these wastes are also increasing, and it is estimated that 22 million metric ton per annum these plastics will be going to be used in India by 2020, and the situation is going to again the in another way the hope of recycling is growing, and in another concern is that the waste is growing. So this is what the scenario survey conducted by this statistical survey made, and the consumption of the plastic waste is in metric ton in volume in metric tons is in a potential way, and this is the statistic till now they collected that 8 to 1,000 metric ton of waste is till this 2020 is generated. So the growth, where the demand is there, growth is there, and now this demand is being increasing for this plastic. Either you can tell it agriculture, or you take it in infrastructure way, or you take it in a packaging industry way, or you take in any other growth area. Now it has been another area has been used this plastic protective equipments, and that has been used for mostly now these PPE kits for safety of against this corona. And now whatever the use is, but what about the after use? because after use, when that is not being used and being thrown after the use, and then the next issue of waste is being started. So it is from the survey from this Times of India that India has 26,000 tons of plastic waste. That is a problem, and so the problem is major in the capital city of India, and in all the growing cities, top 10 cities. Now this waste is increasing day by day, and all the waste to recycle uh, is a tedious way, but still the scopes are there, and still many no startup and many industries are required so that the this waste can be recycled and this waste can be reused, because the generation of the where is the most consumption of the plastic waste are generated now. Currently, per capita plastic waste is 6 kg per capita, and mostly plastic collection and recycling rate is 60%, and the waste what it comprise, the most waste percentage from LDPE, और जो हम पैकेजिंग थैली पकड़ के मार्केट में या फिर छोटा सा थैली जो यूज करते हैं ना, दैट कंप्राइज अ मेजर वेस्ट. अनदर इज पेट बॉटल, जो पानी का बोतल हम यूज करते हैं, दैट इज द अनदर इशू. पीवीसी, जो पॉलीविनाइल क्लोराइड जो यूज करते हैं डिफरेंट फ्लोरिंग एप्लीकेशन के लिए या फिर बिल्डिंग कंस्ट्रक्शन के लिए, दैट इज द अनदर वेस्ट. एचडीपी, आपका जो पॉलीथिलीन यूज करते हैं, हाई डेंसिटी पॉलीथिलीन इन टर्म्स ऑफ पाइप्स और इन टर्म्स ऑफ एनी एक्सट्रूडिंग डिवाइसेस, दैट इज अनदर इशू. And then polypropylene, polystyrene, which are all the plastics which comprise of 80% waste, and that is the major concern for the plastic waste. And then non-recyclable plastic compositions, and these all coming under the best thing is that they can be recycled and they can make a value. We can make a value addition for this plastic waste. And then non-recyclable plastic compositions like 20% is from this either alkyds, epoxy. They are coming under the thermoset epoxies or cross-linked epoxies and cross-linked metals. And then melamine, formaldehyde, PU, all these cross-linked metals are compressed of 20%. They cannot be recycled. So that is another issue. And what are the threats? They are non-biodegradable. Segregation is issue, and then littering and burning and dumping. These are the issues for this plastic. Now in India, the challenge is that skill is less, no incentive. Those who are rat pickers, they are paying less, so that's why they are losing the interest for this. The picking up this waste metals. Awareness is less. People are not awareing still, though government's regulations are there, penalties are there, and but still people are not the still the same people are throwing this plastic waste here and there, and that lack of awareness is a issue, and collection and transportation cost is high. There is no subsidized scheme from government is there for collections and transportations, and then all that involves manual process till today also these tractors are coming, 4 5 laborers are there, they are manually picking up this waste, taking to another stations, then again taking transportation to the waste recycling is a tedious way. So these are again the transportations and cost involvements are issues. Policies are there, but mandatory forceful measure of the policies are not there till now. In Bhubaneswar also the below 50 micron plastics थैली का बैन है, लेकिन फिर भी आप कहाँ पे भी देखिए प्लास्टिक थैली continuously it is market हर जगह मिलता है और so that is lack of awareness. बायोडिग्रेडेबल प्लास्टिक को अभी जस्ट 4-5 दिन पहले न्यूज़पेपर में निकला था कि उड़ीसा स्टेट पॉल्यूशन कंट्रोल बोर्ड से कि डोंट यूज दिस प्लास्टिक polythenes which are below 50 microns and use biodegradable plastic polythenes. And because biodegradable polythene थोड़ा महंगा है, is 5 to 6 times costlier than this regular use plastic polythenes. इसलिए अभी तक मार्केट में क्योंकि जो शॉपकीप छोटा छोटा शॉपकीपर they are not cannot afford that, so many other plastics waste थैली का यूज हो रहा है, but still it is not a the way of still policies का forcefulness is less, and implementation of policy is also a challenge. And then what is the innovativeness for making this collaborative approach to address these challenges? नाउ ये सबको इसमें कोई नया नहीं है कि रिडक्शन रीयूज रिसाइकल ये जो मेन लोगो है गवर्नमेंट का कि रिड्यूस करो यूज करो एंड रिसाइकल करो और ये इट इज नोन टू ऑल बट whether these facilities are there for making reuse, whether the sufficient resources are there for use, whether the sufficient the infrastructure facilities are there for recycle, but still these two things are are less. And prevention and reduction, it is from the all the customer side, but when there is a use, when you have use, then you have to you have to take the use of the plastics, क्योंकि हम बहुत सारा एप्लीकेशन प्लास्टिक इतना वाइटल हो गया है कि that is made a compulsory approach for making use of the plastic. So now the main things are there that 100% recovery by processing, by co-processing. By, so 100% recovery is in India. It is still it is at 60%. In record, it is showing 60%. In reality, it is less. So, and incinerations, landfillings, waste to earth, recycling, incineration, and landfilling. These are the things which India is currently practicing for reducing of the waste. Now, the plastics, if you check about where the real picture for these plastics, it is from one survey that the production, if it is 8,300, then the use for different applications is 2,500, and recycling is 600, and where are others? They are all discarded. Discarded means all are incinerated. What is incineration? Simply buried under the soil. But when you are burying a plastic in the soil, so that means it is a threat to the ecology, because it cannot be decomposed, it cannot degrade, and it can live in a soil for a very 2, 3, 4 human generations. So when that will be buried in that, that means it will ultimately, this plastic waste is going to meet with water and it pollute the ground level waters, and ultimately we are drinking all those waters. Lots of people they are using, water is a vital resources, so we can't make pollute of one important resources in terms of using this by making insulation, by making this boring of these plastics. So another use is that for making these plastics to making energy by boiling these plastics, and then those boiling of plastics taking energy, and those energy is used for the power generations. But still, when we are boiling the plastics, or whatever the technology used, but whenever we are boiling the plastics means some toxic gases are also involved in those plastics, and those toxic gases are also going to meet the environment, and those environment are also being polluted. So the thing is, the best way is recycling. And when you are recycling the plastics, the threat is that when the plastic thickness is less than 50 micron, that cannot be recycled. So below 50 micron cannot be recycled means the only one way is that buried under the soil condition. So that's why the government made the ban that below 50 micron should not be used, so that this issue of boring and threat to the ecology will be less impacted. But due to lack of awareness, and things are still worse in India and all Asia Pacific also. Now, what is the solution? Is the best solution is recycling, because when you are making recycling, we are giving a value addition to waste. So that means when you are making recycling, just collection and different recycling plants, they are being used to or converting to different plastic products, and then they are being disposed. So this is called as the linear economy, where the plastics are being used. uh, when the plastics are being produced and thrown up, then that is a linear economy. But whereas the plastics are being recycled and again converted to the value added products, then that is called as the circular economy. So that means one part of the product is used in one way, and again the waste is used in another way. So that means the value addition is there for this waste. Now, this current economy for the plastic extended producers' responsibility is that the plastic waste can be designed which can reduce the threat to the environment. They can they can be transferred to the responsibility, cost of collections, and that involves the cost of collections and disposals. But when these plastics are being used, then ultimately they can make a zero waste, and they can make a solutions to the different approaches, solution to the different waste. And so day by day this waste recycling government is also giving more interest to the waste recycling, so with subsidized schemes and also giving uh, facilities like land and all the things. Even in plastic Paradip plastic park is being set up, where this facilities government is providing the subsidized facilities for the setting of this waste recycling plants there. So, what is the benefit when we are making a recycling? It is a financial benefits, and it is also resource conservation, makes engagement of the lots of the manpowers. It saves energy, and it makes a work together like community development. Now, where is the most to waste plastic comes? Now, the most waste plastic comes from this packaging industries, because packaging industry is one thing what after use immediately that is going to be waste. पानी का bottle एक लिया और after just completion of that water, now that bottle is waste. एक पाउच लिया मार्केट से खरीद के, now after the use or after using of that pouch, now that is waste. So that means the packaging is the major resources for waste. Reduce this packaging waste, Now, in this era, reducing of packaging waste, nowadays government is making laws that don't use the different laminates, reduce the metallic laminates and metallic laminates inside that, so that those packaging waste can be recycled. Make the packaging to more than 50 micron, so that that can be recycled. And wherever to be used, the plastic packaging should be made in such a way so that that can be easily recycled, and it should be dropped in a proper waste bin so that that can be collected. So there are so many rules, regulations are being made. Even in Mumbai and in major capital cities, they made that whoever the packaging industries, they are making, they are using manufacturing the packaging, they make in such a way so that that can be easily collected and recycled. Many industries now also make a scheme for collection of these used packaging materials. Even in most of the in CPET also make initiation that whoever the bottles collection of these bottles, and then making a reprocessing of those bottles. Even exclusive waste management centers are being set up also through CPET for making use of this plastics waste. So that means the waste is a issue, but wherever the issue are there, even solutions also are there, and solutions are even when we are applying those solutions, that then only the resources can be conserved. So now, if you check about from the CPCB survey that the USA the recycling rate is higher, and the overall India is at 60 percentage recycling, what they are proposing, that recycling in India is around 60%. And sorry, hello,
ఒకసారి స్టాఫ్ రూమ్కి రారా నీ అవర్లో వేస్తాను ఒకసారి రారా సరే రండి
Yes.
సార్ ఏమన్నారు
Sir,
చెప్పారంటే
hello,
yes, sir. Sir,
hello,
sir, my voice is audible.
hello.
Sir,
Yes, yes.
sir, I mute all the participants. Sir, now you can start, sir. Yes.
Okay. And the waste is what already we have according to the CPCB survey, we have already shown that the 60% of the waste is there, which is recycled. Now the problems what we have already discussed. Now the solutions. What is the solutions? Now how to make, and what are the the opportunities are there to make those. Now waste plastics, where is the use of the waste plastics? Now, waste plastic is first is a very good binder. It can bind, the can bind with other metals easily. So, when there is a good chances of a good binder, that means the chances of using in roads as a construction of road can be used. So nowadays, mostly waste plastics now they are being used for making construction of the roads. Even recently, government is also focusing of using of this waste plastic in construction of the roads. Plastic, or making a plastic waste shred or plastic waste based concretes, which can be directly used for the construction of the roads. The benefits are that life of the roads are increasing, and the and these roads can be, the performance of the roads are increasing, and the the major effect, distortion for the road is the moisture and water and rain. So that can be prevented, because plastic is well known to the protection against the rainwaters, and so it is impacting to abrasions impacts. So in that way, it is giving increasing the life of the roads, and even in CPET also, in 2-3 CPETs also, the roads are constructed, in all that CPET roads are constructed using this plastic waste. And right now CPET is also taking 2-3 projects where this plastics waste materials are being used for making construction of the roads. Another, whatever the things are like solid waste, so another waste is a e-waste. E-waste means electronics waste. Now electronics waste, because we are now day by day increasing this electronics products. ये मोबाइल हो सकता है, वॉशिंग मशीन हो सकता है, कंप्यूटर हो सकता है, all household right now they are using the uh, higher quantity of e-waste, and that is also the another waste segment which is growing day by day. And this waste segment carries some toxic metals, and health hazards are there with this e-waste. And if you check about the statistic what is being made by this statistica, uh, that where the India is just after China, US, Japan, the US is there in the next in India. So this US is now growing a potential way, because most of the the in villages also, in rural uh, rural areas as well as urban areas, now they are using a tremendous way these e-waste products. So that is another threat is going to become uh, for this growing up a huge potential of the e-waste materials. Now this e-waste products that can be also used for the value additions, and this electronic waste also can be used in many ways for recycling, for making the different products. Even in mostly what these waste metals are there, electronic waste metals are there. The electronic metal comprises of ABS, acrylonitrile butadiene styrene, high impact polystyrenes, polycarbonates, and then blend of ABS PC metals, polyvinyl chloride metals, polymethyl methacrylate metals, and polystyrene. So these metals are considered as a engineering plastic metals. Engineering plastic metal means these metals are higher in strength and higher in value addition. Whatever the other waste we have discussed in previous slides, those are all commodity plastics, and those plastics are being used for the household uses, and these used are engineering plastics, and these are also used for making the electronic components. Now these components are being used in many applications, and the value addition of these components can be made by proper segregations, क्योंकि हर मेटल का प्रॉपर्टी अलग अलग होता है. सो अलग अलग मेटल को प्रॉपरली सिग्रीगेट करना एक इश्यू है, एंड जब हम हर मेटल को सिग्रीगेट कर सकते हैं, देन इसका जो वैल्यू एडिशन है, और यूएस्ट मेटल को हम डिफरेंट वैल्यू एडिशन कर सकते हैं, जैसे हम डेकोरेटिव ग्लास पैनल्स, या फिर वुड पैनल्स, या फिर एक्यूस्टिक पैनल्स, तो डिफरेंट पैनल एप्लीकेशन यूज कर सकते हैं. इसको हम डिफरेंट आर्म चेयर्स, and a different household components, you can make it. Now another waste is biomedical waste. So biomedical waste means जो waste generally from medical components it it is being produced, means hospitals and microbiology labs, biotechnical industries. So biotechnical industries, so all that industries they are basically producing of this waste, biomedical waste. So this is another concern of the waste. Now, first we have seen the waste are from household waste or commodity waste. Second, we have seen the e-waste, electronic waste, and third is the biomedical waste. So even this plastic protective equipment kits, they are also coming under the biomedical waste. Then labs, microbiological labs, and then medicals. So all their day by day increasing potential or their the increasing of this plastic waste is going to be the waste plastic biomedical plastics are also going to increase in a very high. Now the concern is that these biomedical waste are being used either with the different patients, or it is being used for the storage of this either bloods, urines, or it can be used for the saline water, or it can be used for the kidney dialysis membranes, or it can be used for the the different life protecting equipments. So, and after the end of this use, it carries bloods, it carries salivas, infected patients, the different infected patients, viruses, bacteria. So recycling of this biomedical waste is not that much of an easy way like the commodity waste or electronic waste, because the biomedical waste carries most of the infected infections. So the currently all the hospitals are being forced for collection of their biomedical waste and proper disposal of the biomedical waste. Now, what they are doing is currently how they are disposing. These biomedical waste are mostly not recycled. They are mostly not the converted to the value-added product. Only the thing is that either they are going for incineration or they are going for the burning of this plastic biomedical waste for the recycling. Because for safety concerns, it cannot be again to come to the recycle way to come to the public, and nobody can sure that when the plastic biomedical waste are being cleaned properly and then uh, properly the sterility has been maintained, so nobody can guarantee for all this. So mostly right now the current trend is that it is either being dumped or being making gone out for making the the lowering to make lower of this biomedical waste. So this biomedical waste can be recycled either giving a proper treatment, either it is a microwave treatment, and through the microwave treatment this can be the properly either first it is properly cleaned, and then by using a microwave at higher temperatures for lower time, whatever the infections that can be tremendously reduced, and then they can be used for the different value addition products and has also tremendous potential. Currently, the research and currently lots of funding from DSTs, BBTs, are the growing way for using this value addition to the biomedical waste. Most of the now the medical professionals, aims and uh, lots of top-notch government medical colleges are currently doing research on this utilization of this biomedical waste in various applications. Now about CPAT, it has a national presence in every almost most of the states, and the CPAT is being mostly resources of the it has most of the resources for plastics, and it has all the facilities for the using of the plastics, converting of the plastics to value additions, and it has top-notch research centers. It has top-notch tooling centers, processing centers, testing centers. So it is working in a very tremendous way for using of this or giving value addition to the plastics. Not only the value addition to the plastics, also it is in a role for the waste recycling also. There are so many research are going on here in CPET Bhubaneswar. There is one laboratory is there, which is a exclusive research laboratory out of three uh, focused research laboratories of CPET. One is at CPET Bhubaneswar, and which is working in various ways for this using converting this plastic waste, and for many applications it has been working in last 6 to 7 years. Many patents, many technologies are being established by CPET Bhubaneswar, and CPET is working in such a way, and it has been the technologies are also being transferred to a top-notch industries like Ford, Hyundai, Mahindra, and the first the work has been started with the automotive waste, where the automotive waste are being recycled and value converted, and they are converted to the biocomposites, and those biocomposites by using those metals are being reused, and the biofibers are being used for the converting to the value addition products, and those products are also technology transfer to one technology transfer to already to Mahindra, and approach is there to other industries also. So we are making value additions according to the their requirements, and developing as per the requirement of this bio composites. We have processed that, and we have studied all the parameters: temperature, pressure, and value addition, products parameters, and then we have studied also the property wise, and being applied in different fields of these automotive components, and already works are being made for the value addition to the used components, and worked with many top-notch industries like Ecorico, ePorisara, and where this waste e-waste products are collected, and they are segregated, recycled, and then value added, and then converted to value addition products. Being many products are developed, and those are also being used in many currently in many applications. Now, just I am showing a video where the CPET's role can be seen. Now, this is the exclusive US lab is there at CPET Bhubaneswar, and this US lab is totally set up with support from the Department of Science and Technology and Ministry of Chemicals and Fertilizers, where we are collecting the different US, and then different approaches are being made like washing and proper cleaning, shredding, grinding. There are many approaches are being made for the value conversion of this plastics into the waste to value-added products. Okay, that was the whatever we have seen. That is basically e-waste recycling. What is an exclusive setup is being made here in Snippet Bhubaneswar, a research laboratory of like LRPM, where this e-waste recycling setup are there, where the collection of this e-waste and then value addition of this plastics are also there. And many of the industries who are going to be set up the US plants, they are coming here and they are looking those demonstration that how to make a value addition products in a life in a life, and then they are purchasing of all those required equipment and they are setting up the plants, and many of industries they are also witnessing this plant. Not only this, another exclusive waste management center is there, which is at Guwahati, and those waste management center is actively used for the collection of this plastics from different cities through trolleys, and this separate personals they are have exclusive manpowers. They are collecting the waste. Also, they have contacted with many recyclers, rack pickers. They are all collecting the plastic waste and they are being, giving to this waste management center. And in the waste management center, there are different machines are there already set up, and those are basically converting to those waste to different value-added products, and they are selling to the markets. And those making the plastic waste to the different oils and plastic waste to the products. So there are many applications products are going on there, and the many and those plastic waste plastic products are directly given to the many distributors and many industries also those who are in the way of making value added products or waste recycling they are also taking the benefits from these plants. And also CPET is working in such many ways for making this recycling of this packaging industries. There are so many packaging industries. The research is going on with Nature Tech, ITC, PepsiCo, where their packaging films are recyclable plastic packaging films are being produced, and those recyclable packaging films are also the R&Ds are already completed, and packaging films of recyclable packaging films are being developed, and they're being handed over to these industries. Many industries are presently also coming for making the recyclable packaging films, and that research is also going on in a big way. And also CPET is collaborated with UNIDO for this recycling for the recyclings, and is acting in many ways for making recycling of these products and also giving the research technologies sharing with the UNIDOs, and combinedly UNIDO and the CPET is acting in many ways for recycling waste, making value addition to the waste. And this is what the snapshots of this waste recycling activities. What is at CPET, IPT Bhubaneswar with a top-notch research LRPM, and the many research scholars, PhDs are being generated, and many research scholars are working in this recycling plants, and they are giving their PhD thesis have been submitted already submitted, and many industries who are in collaborations. Our research professionals are working for them. Many patents are also generated for waste recycling areas, and already patents filed. Many patents been granted for recycling areas. Many publications are generated, and those publications are also many publications are also under the way, and already in recycling areas, many works have been carried out. And the facilities of CPET is very top-notch facilities for the waste recycling area and waste management areas. Almost, if you look about the plastic waste, you can see all the maximum facilities are available under one roof, and all those equipments can be utilized for converting the uh, recycling of the plastic waste. We have a tremendous subfloor of processing comprised of many big scale industries. These equipments are not a demo scale, not a lab scale equipments. These equipments are all industry used equipments. Many industries are using these equipments for converting the products. Many plastic products are being produced with those equipments, and our equipments are running 24 hours, and we are giving uh, uh, this you are utilizing the many industries are utilizing these equipments for giving value addition products, and also we are facilitating those startups who are growing in this area. They are also coming here and utilizing our facilities for making the value additions and uh, making their products, many plastic products. We have a very good processing facilities, compounding facilities, testing facilities, and then characterization facilities with all most high-end equipment. And those high-end equipments are can be used, and very huge labs are there with most advanced, sophisticated facilities, and all the equipments are in working conditions, and all the equipments are used by not only Indian industries, many foreign universities, many foreign industries, and like Boeing is there, Atlas is there, Atlux is there. So many industries are there which are uh, making R&D or research and development with using our facilities, and research are going in a big way, and many DSTs, DBTs, DSR projects are also going on. This laboratory is also recognized by DSIR, and also this is being even our Biju Patnaik universities, our CPET Bhubaneswar is nodal research center. And, many PhD students are there, PG courses are there, MTech students, MSc courses. All the students are also working in very big way in different projects. Characterization wise, it is very rich, and all the facilities, TSCs, TGA, DMA, HDT, MFI, thermal conductivity, and many equipments, instruments are there, and which are being used in many way, and not only for research. It's very big way. It is used for the industries, commercialization ways, and all the commercialization aspects like test charges and everything is there in public, and every facilities are there in public, and everybody can use such facilities, testing and characterization facilities, either for their research or for their uh, product development. Even we are providing 25% discount for this MSME industries, and for research professionals also huge discounts are. So there are many characterizations. Either you take it flammability studies, or you take it thermal studies, or you take it for morphological studies, or you take it in compounding, processing, tooling, design. So all the facilities are there in terms of plastics. Many facilities are there. So, and for this e-waste, in many areas already work has been carried out uh, by our research professionals, our research scholars, PG students, MTech students, and research scholars. Also, we have developed some value addition products from this e-waste metals, and those value addition products are in many ways the characterizations has been completed, and the products are also scale of the commercializations, and uh, many MSDS master safety data set has been generated for the materials which are being developed, and they are in many way the components are being characterized, and those raw materials are also being the characterized and satisfied that it can be used in many way for this uh, commercial applications, and those products are also being handed over to many industries, and the technologies are being handed over to the industries that shows the way that how to utilize or how to recycle the plastics waste and to convert to the value added products, and what is the commercial aspects of the conversions, and what is the economical way, and how to reduce the cost, and what is the value additions, and many recycled products are being produced here, and value addition products, and that are being also studied in many ways. And if you take it one study that waste plastic like meter cover what we have generated from the plastic waste, the metal being developed by conversion of the US metals. When you take it a original product, its rate is around 78 rupees per kg. But when you convert to the US raw metal after the US waste metal, that is around 22 rupees per kg. And those metals are can be used for this either make a metal cover or make a charge components or make arm covers. So that is the value addition. After value addition, now this is the benefit what we are going to make, and those raw metal has many applications, many industrial and general purpose applications are there for this valuable products. Life cycle analysis are also made with these value products what we have produced, and the tremendous properties are being achieved, and it has been found that these products are retaining of this strength and impact strength. And then reprocessing cycles are also studied, that how much times these used metals can be reprocessed, and 5 times we have reprocessed, and the strength is also uh, checked out, and it is found that also a very good retention of the properties can be maintained when we make a recycling, many number of times of recycling of these products. And then many properties like flame retardants, other toxicity properties are being analyzed and studied, and found a very good results that which can be used in many applications very well manner. And also we have checked about according to the government regulations heavy metals, and also we have made recycling in such a way so that the heavy metal components are being separated, and only the safe plastic products are being made, and that has been also tested. And like lead, cadmium, and copper, zinc, whatever the toxic elements that have been found, and it is all parameters are found very good, acceptable range. So studies are being conducted, and the products are being produced, and many products are commercialized. Many industries are also took the benefit of recycling of this plastic waste. So many value additions are being made, many raw metals are being generated, and properties are found in a very good properties are being found. And the metallic components, not only the plastic components, also the research are made for value addition of the metallic components, and that has been also many value addition products are being produced. And the plants what we have, this is the plants what we have for making recycling of the waste. So how to the process of the things are there, and how to make value addition of the waste to the value added products are there. It is one demo plant but already we have established here. And the commercialization aspects also we have checked about the how to make commercialization of those plastics which are being used, and very successfully we have found that that can be a very tremendous way it can be commercialized, and many applications are there, many validations are there, and potential way is there for making this validation this plastic waste. And the facilities are there for waste management. One facility is there at Guwahati and another is at Bhubaneswar, recycling demo units, and those are ready to see and demonstrate the waste recycling, and to check about how the waste can be in efficient way can be recycled. So this is all about the approach what being made by the CPET for recycling and the concerns of the recycling in the current situations, which requires a lots of requirement for the waste management in the current scenario. So I hope these things are clear for the concern for the recyclings, and any the questions or something may ask. Hello, hello.
Ah, yes, sir.
Yeah.
Now this is open for discussion. So anybody having any doubt in this can ask here.
Good morning, sir. Hello.
Yes, yes, sir.
Hello.
Good morning, sir. I'm Samir Nimkar from Bharati Vidyapit. I want to ask whether life cycle analysis study has been conducted when we are converting waste into another form or another usable form. Thank you.
We study.
LCA, life
Hello.
cycle analysis. LCA study, life
Uh,
cycle analysis.
yeah, life cycle analysis already have shown. One study has been made already. Just this is the life cycle analysis what being made for the the packaging recycled products, that how much it can be how much times it can be recycled, and after each recycle, what is the after each recycled what is the property it can maintain. So number of reprocessing we have made, and each time the strength reduction, the strength is going to be the reduced, but still it has a potential for recycled, and it has a potential for the uh, potential for the applications in many ways. But because all the waste cannot be used in one, all the waste are being used with mixing with the virgin metals. So still this waste has the potentials, and they can be used in many. We have studied only for 5 recycling, but it has a potential for 10 number of recyclings, and it can be accordingly. We can check about the products, and it can different product applications we can be made. Also, another study we have made for recycling is we have made the environmental studies and check about the retention of the properties, and also found that that is also when exposed to the environment, like UV exposures or xenon exposures, and then we have found out that the properties are also retaining there, and but though we cannot use for the long hour exposures of the UV, because UV has intensity for deteriorate. But however, the recycling metal has stability to the retain under the UV environments also. So like that studies are there, we have conducted, and when this is a area of research, many studies we can go ahead also. But it has a life even after recycling.
Thank you, sir.
Any other question? So I think there is no more question.
Okay.
Yes.
So
So,
already I have shared also my contact details.
Sir, excuse me. Good morning, Professor.
yes.
Sir, shall I proceed? Yes, sir. I am Dr. Tanuja from Sairam Engineering College. Sir, is
Mm.
it possible to convert the plastic into, that is bioplastic, into manure or fertilizer, sir?
You want to convert the bioplastics to fertilizers.
Yes,
See,
sir.
the fertilizer is different because fertilizer means maybe carries about some chemicals or something. But suppose bioplastics is 100% degradable because cellulose is one of the biodegradable plastics. Okay, and
Yes, sir.
how the bio how we are, because somebody is telling that we are making a biodegradable plastics, so that means whatever the material he is using for making biodegradable plastic, that should be 100% recyclable. So the standards are there because suppose somebody is selling the biodegradable plastics, that means there has to be certified, the plastic material should be certified from any CPCB certified agencies that that material used is a bioplastic. So what is bioplastics then? Bioplastics are such materials which are 100% 100% degradable. So
Yes,
when
sir.
we are asking about 100% degradable, that means 100% biomaterials are there, like polylactic acids, like cellulose. So those plastics are being made by those metals of 100% biodegradable metals. Now, if you're asking about the fertilizers, those plastics, suppose your use is over and you have dumped that plastics to the soil, that plastics can be the degraded easily, means their life cycle is 180 days. It is considered that 180 days is a total the burying of the life cycle for those plastics. So that can be used, but we can't tell that that is a fertilizer. That can be consumed by the plants because one of those test is there already. How to check that whether that is biodegradable? In that test, what we are doing according to the standard, that plastic is applied to the soil in a the aerobic environments where this composting plants inside the composting, and then we are checking that whether that is completely compostable or that is consumed by the earthworms. Point number one. Second thing, whether those plastics are used in a plant and how the plant is growing. Also, the test is there, and day by day, every day, the growth of the plant is being monitored. That means those plastics should be consumed in the soil, and it should be give the support to the plant, and that should not the effect to the growth of the plant. All that studies are there in the according to uh, the standard one. So in such a way, in that way, we can tell that it can be the giving to the fertility to the soil, but I can't tell that is a fertilizer. Only test shall tell that it should be consumed by the soil, and
Yes,
it
sir.
can
Even
be.
I too have the doubt, sir. That is why I just want to clarify because I saw many papers coming like that. That is why I just want to clarify the doubt, sir.
We can tell that the it is a fertilizer. Fertilize something which is giving fertility to the soil. It is consumed by the soil. It is the earthworms are taking it as a food, and in that way it is giving benefits. So you can't take it as like it is a fertilizer. Research papers are doing maybe converting to the the fertility by adding this degradable bioplastic with many urea or something, and then they are giving the food, giving the making soil fertility. They are maybe using but it is costly way for making fertility to the soil because bioplastic is not a cheap 400 rupees per kg it is, and after value addition it is 500. So it's been costlier.
Yes, sir.
Okay.
Yes, sir. Thank you, Professor. Thank you very much.
Hello, sir.
Madam.
Hello. Yes, sir. This is Dr. Prinsip from Central University of Jammu. I just want to add something. For example, we are trying to manage the plastic waste. So, is it not like this that we should try to find out alternative ways where we should totally avoid the use of plastic? For example, I am working in green chemistry, so its first principle says try to prevent waste rather than to dispose it off later on. So, just want to have your suggestions on this.
Madam, your concern is that whether plastics can be replaced, correct?
Yeah, matlab, for example, we are spending so much. For example, you are spending so much on this plastic waste management. So, I think it should be that we should try to find alternative pathways for this plastic use. Just want to
Mm,
know your suggestions, your advice.
Madam, alternative plastics. If you ask about something is alternative to plastics, see, alternative to the plastics are there because already we have already lived in that era where plastics were not there. Because before 20, before 15 years or something, where the plastics was not there, and we have seen that era also. So right now the plastics are going in a big way because of the cost. No, it is very cheap cost. Now the people have started to drink water with aluminum bottles, glass bottles, and no the but that is costlier. You know that when you go for a plastic bottle and for drink water, it is only the 50 rupees, 40 rupees BPA bottle. But when you take a aluminum bottle, copper bottle, it is somewhat cost conscious. So alternatives are there, but when you are checking about the cost, we have because for making a big way, into replacing the plastic means we are thinking some products which are less cost than plastic. But right now, even we are struggling for replacing the packaging metals because right now government has made so much regulation, so much forceful for the reduce this plastic polythenes or something, but and the alternative is made like biodegradable plastics, but still it is there. Second thing is that the plastics are basically a non-toxic metals, and basically plastics as a whole is not that much of harmful until unless it is not being thrown up. When it is being thrown up, then it is the threat to the environment. But when you use it in an effective way, then it is the best product. And we think in such a way that plastic is protecting your forest, because before we are making use of many wooden products, but now all those wooden products are being replaced by the plastics. If suppose plastic was not there, then I think all the forest will maybe vanish. But the latest developments are going on, but still I think plastics is such a versatile product. It's very difficult to replace in this era. Rather than only the thing is that awareness, recycling should be grown. Because still, if you take about the higher advanced country like US and something, they are using in many higher way the plastics. Then their per capita consumption is very high. So that means they have also the usability of the plastic is very high. So is a little bit difficult, not a little bit, very difficult to replace a plastic metal. And still, plastic metal is going to rule. Only the thing is that we have to check about the processing and waste recycling. That is the only one way where we can see a better tomorrow.
Okay, thank you, sir.
Any more questions? Okay, so I think there is no more questions, sir. So thank you, sir. We are fortunate to have you as one of the speakers. Your presentation gives lot of knowledge on how to handle plastic and the role of CPET in this particular area. So thank you, sir. Thank you lots.
Thank you, madam, for thank you, madam, for giving one opportunity. And even I am not aware that many universities and many the professors are all online. So it was very nice to have a discussion on this era. Thank you. Thank you.
Sir, there are so many requests from the participant that they want your presentation, sir. If you kindly share that PPT with me, so then I can share with the participants, sir.
Most of these things are our internal research areas and other things. So I have to take a permission to our own concepts and
Yes, sir.
developed concepts, and many things are there. So and whatever other thing that is a generalized collection, data collection, like from CPCB or many statistical agencies.
Yes, sir.
So
Okay, sir. Okay, sir. If any confidential matter is there, so that is should not be shared also. So no matter,
yeah,
sir.
but because
Okay, sir.
many research are also on the way.
Okay, sir.
Okay.
Okay, thank you, sir.
Thank you.
And dear participants, I have shared the feedback link and the attendance link. You can there you can give your feedback and also attendance. And the next session, the second session is from 1:30. So see you all during that session. Okay, so thank you all.
Thank you.